Welcome, welcome to week 3. We're going to talk about grade define. I've got the module up over here, and you should see my little hand wiggling around there. Uh, Weekly overview is just a couple of things, but they're really important things that we're going to be doing this during this week. We'll take a look at these couple of objectives here. We need to know the difference between slope ratio and percent grade. Now, we're going to go into this a bit here in just a second, but slope ratios are usually used on larger scale operations such as highways and things like that, where you have a pretty big slope that extends horizontally and vertically quite a bit. Now, when you get into putting a sewer line for under a house leading to a septic system, you're going to use percent grade. And because it's just such a small incline, like a lot of septic lines want their grade to be like 1%. So, like, gee whiz, 1% over 100 feet is a footfall. And there's a way to calculate that. And there's a way to calculate these uh, uh, needed slopes or required slopes that we'll talk about here in a little bit. So let's move on. See if we can find something. See if we can find something else. So the name of the title of the module is Grade Define, and we're going to talk about that here in just a minute. Uh, Actually, we'll probably go ahead and click in here. There's going to be a video. Uh, this is where this video is going uh, here, and as soon as I get it done. So, but let's go on ahead and jump in here on what uh, this book says about grade. I'm going to read from this. Well, no, I'm not going to start with this three-dimensional uh, figure here. What you're looking at over here, where my arrow's wiggling around, is a slope. It's a built slope, and it's a fill slope in this case. They started right here at the toe of the slope. They came in, uh, don't know what this slope is. It's just a good way to see a 3D slope. But imagine profile. When you take let's say this is a big long chunk of cheese or some kind of bread. I don't care what, let's stick with cheese. And let's slice off an end of it. Say the cheese goes on down this way a ways and on up this way. So once we take that slice off and eat it, consume it, or throw it away if we don't like it, this is what we'll see. But there, there'll be little holes that we will see, just like you would see air voids in bread. Well, there'll be some air voids in this cheese, and that's what we'd be seeing right here. So we're standing right here, or it's sitting on a table, and we're sitting at the chair, and we're looking at the cheese, and we only see this triangle. All of this other stuff is hidden, but it's there. It's solid from this end to ever how long the block of cheese goes. So if this is to be or is a 2-to-1 slope, in other words, if this slope has is 2-to-1, that means it goes 2 foot horizontally, like starting right here, 2 foot horizontally and 1 foot vertically. 2 foot horizontally, 1 foot vertically, 2 foot. And you see it keeps building up. So when we come in here and build this fill slope, it's flat. All this area is flat right now. the first thing we'll do is we'll bring a scraper down here, and it'll drive across here, and it'll dump a lift. That's a scraper wide uh, mass of material, and he's good enough. We want a 12-inch lift because we're 2 to 1. So he's going to dump that lift down there, and so that's going to be a 2 foot slab here, and hopefully by 1 foot long. So he's going to come in here again and do the same thing. A 1 foot thick slab, about 2 foot wide. That would, you know, whatever it takes to get over here. And it's going to be 1 foot deep all the way from here over over to there. Then he's going to come in here and he's going to move over 2 feet, and he's going to drop another 2 foot wide, whatever, 2 foot wide slab. And so what you're going to have is a step up of 1 foot and then 2 foot level. It's going to continue doing that until he gets this height right here. Now, this dirt is going on, he's dropping this going on just as I said the cheese was going on. This is going on forever, how long they need it. Imagine this being the slope on the side of a highway. So, or anywhere. So once he gets that 1 foot across here, he's going to come in here and he's going to move over 2 foot and drop another 1 foot lift all the way down here. Then he's going to come around, move over 2 foot, and drop another 1 foot. So what you're going to end up with is a set of bleachers or stairs made out of cheese. It's going to be, at first, it's going to go up, over, over and up, over and up, over two, up one, over two, up one, over two. So it'll look like a set of bleachers made out of cheese, or stairs made out of cheese. So when they get through with that, they will come along with a dozer, in many cases, that has what's called a slope board on it. It's an attachment that goes on the front, and it just is a big long bar that lays down, and that dozer on the left side or right side, whatever side of the blade you want to hook it up on, and it will cut the stairs out, and then all you'll have left is a smooth slanted surface. It'll be a slope. Now, as he's dumping these lifts, let's call them, and making these stairs or bleachers, if you can picture that, he's going to be setting stakes on his way up. He'll set these stakes, these are toe stakes, that's what. Then when he dumps enough dirt to get up higher than where he wants his second stake, he will set the second stake. And we're still building this thing and cutting this thing because it's still bringing dirt in, going up, cutting it down, making the stairs or the steps, and so forth and so on. So there's some things to point out here. Is it's real important that these stakes are truly aligned. They're saying this one's off a little bit in this direction, but you need to be diagonally aligned. That's how important it is to get these stakes. When you put a stake in the ground, it needs to be plumb and solid in the ground, and it needs to line up with the line where all the other stakes are, both uh, this way and that way, and diagonally. So all that needs to be done. So let's talk about what is the term grade. It says it has several meanings. When any equipment operator calls for grade, the individual merely wants to know where the elevation of the proposed grade is, such as where the top of a fill or the bottom of a cut may be located in reference to the particular point which he or she is working. So from where they are now, how much deeper do they need to go, or how much higher do they need to fill? Unless the operator can visualize the level or plane at which the cutting or filling must stop, the individual cannot hope to do the job. Now, do you recall in week 2 you did this grade boot thing where the guy was looking at a 3-foot boot in the beginning and he was taking a shot and say he got a reading on his engineer's level of 2 and 8 tenths, then he would tell that operator right then that he's too high, he needs to cut 2 and 8 tenths. So that's the way this happens. That's the way it goes on. You got a guy setting stakes. You got a guy following who's helping the backhoe or dozer, whatever's working, either make his way down or her way down to the desired cut level or the desire up to the desired fill level. So operators know that when they have reached the point which it is said to be at grade or on grade, they have completed the work of cutting down or filling up to a proposed grade level on the project grade line. Still another definition, the grading plane of a construction project line is the slope or the numerical rate of ascent or descent of the line. In other words, not many things on a construction site other than a house pad or the building pad are level. Everything else will have a slope or a fall for drainage purposes. It's just imperative. Next time you're driving down the interstate, if you're the passenger, look to the right and to the left, and you're going to notice some things. You're going to notice some diversions and some slopes, and you're going to notice some diversions in those slopes. It's taking that water where the contractor wants it to go, both while it's under construction and especially when it's finished and it starts raining. You do not want standing water on the road, right? So that's why roads have a crown. Usually, a highway, depending on the width, would have a 2% fall from the center line to the shoulder on each side. So, and we'll get back to that. That's an actual problem that we can solve when we get into percent grade. Most of this talk we're going to do will be centered around slopes instead of percent grade. So as I said before, slopes are usually used where there's a lot of work to be done. Percent grade is used on more smaller operations, like I said, of laying a sewer line or stormwater drainage from catch basin to catch basin. All of those things none of those things actually are level. They're all falling in certain different directions, or rising if you're looking the other way. So back to this illustration, this three-dimensional look at a slope. It says the rest will be profiles. So that means we're mostly going to be looking at what is an obvious triangle here. This one is a one-to-one slope. That means for every 1 foot horizontal, it's going up verticals 1 foot. This is a 1.5 to 1. So it's going horizontal 1.5 and then up 1 and then 1.5 up 1. Over here we have a 2 to 1 slope. You can imagine this is a much steeper flatter slope than a 1 to 1 or a 1.5 to 1. A 1 to 1 would be the steepest. This would be a little flatter, and then you have this one right here, which is really flat. In this case, if this right here, just to jump ahead a little bit, if this is a 2 to 1 slope, you would take this 2, multiply it by the vertical, and it would give you the 2. This is just a circular problem here, but the calculation to calculate the slope, you take the vertical, you take the horizontal distance, or this right here. This is horizontal distance. Really, it's not from the top down, from a top out to the and to where the toe is. This is the horizontal distance, and this is the vertical distance, right? Okay, so we got it. We got that much done. Let's move along a little bit. This is talking percent grade, and we don't do long division in this course. We use our calculator. This is this is talking percent grade. I can't really read that. That's 3% grade, and this is I'd have to. I don't know if I can even read that. It looks like 1.5. Uh, oh, it is. That's not great. This this is a falling grade of 1.5. I'm sorry, minus 1.5%. That's minus 1.5%. They're arriving at that in the way I don't do it. If I want to know the percent grade of this particular uh, slope, I wonder if I can make this a little bit bigger. A little bit, yes. So that's 1.5 feet. 1.5 feet plus 3%. I'm going to tell you is 3 foot. Okay, here's what you do. You take this 3%, express it as a decimal, which would be divide this by 100, and you'd get 0.03. Multiply that times 100, and you'll come up with 3 feet. That's where they get the vertical. Now, if you have if you have the vertical and you know that the length needs to be 100 feet, but you don't know the percent grade, you would take this 3 feet and divide it by 100. And let's see what that does. 3 feet, I have to get my calculator. I'm sure it's going to say 0.03, but here we go. 3 feet divided by 100 equals 0.03. Well, we kind of knew that going in because 3% is 0.03. We don't manipulate percentages like 3%. We change it to a decimal. When we have this, and when we have the formula for percent grade is the vertical divided by the horizontal, and that's what I did. I took the vertical, which is the little rise right here, and I divided it by 100, and that gave me, and then that equals 0.03. Multiply that times 100, and you get 3%. I don't really go back and forth like that so much when I'm working these, which we'll work a few here in a minute. So that's great. I'm going to flick you over here just for a second and kind of write that down. Maybe you may even be taking notes. Who knows? Let me see if I can do some switching. Not very fast at these things. So we want to get rid of this, and we want to go to this. So this is a little steno pad, and I'm going to write where you can see it, hopefully, percent grade equals the vertical dimension, which over at the other place is, you can't see that, sorry, is 3 feet. So vertical equals 3 divided by the horizontal, which, as you recall, may be divided by the horizontal, which was 100 feet. And again, if you divide 3 feet by 100 feet, you're going to get 0.03, which is 3%. And that's what we'll be using mostly. Now, while I've got this open, let's look at the slope, the formula for calculating slope. Slope equals the invert, just the opposite, the horizontal divided by the vertical. Okay, now let's give this, we gave this one value, didn't we? We came out with 3%. Let's give this one some value. Let's say the horizontal on this one is, oh goodness sakes, 20 feet. 20 feet. And let's say the vertical on this, and we don't know what the slope ratio is. Let's say the vertical is 10 to kind of keep things. Vertical is 10. Well, the formula says horizontal divided by vertical. So 20 divided by 10, isn't that 2? 20 divided by 10, 20 divided by 10, that is 2. So equals 2. So you have equals a 2 to 1 slope. Now, here's the thing we're dealing with. We have the slope to deal with itself here. We have the vertical variable, which can change or be changed, and we have the horizontal. We have 3 things. If we know in algebra, if we know 2 of these 3 things, we can find the other. If we know horizontal and vertical, well, sure, we can find this ratio because it tells us. In percent grade, if we know, know the vertical, if we know, okay, if we know percent horizontal, I'll show you how I'm doing this in my head. We would multiply the 0.03 times 100, and that's going to give us the vertical. Believe me, you just move this decimal over 2 places when you multiply by 100. I'm telling you that. So I'm going to show you something here in just just a second. It's got some writing on it, so I'm just going to leave it on there for right now because it's a problem we're going to do later. Now, to get out of all this algebraic things, because I would have to move things, I have to get the thing I don't know, which in each case was the percent grade. I have to get that on one side, and I have to get all of the numerical stuff on the other side. So I'm going to have to, when I move something across the equal sign according to algebra rules, I have to change the function of it. So I don't want to go through that. That's just another way to make a mistake. So let's take a look at how I manipulate these things. So we got to get out of here and we got to get in. No, I got lost. Let me get back. I know what I'm doing. You're in good hands, I think. Get rid of that. Get this. Okay. Here is a tool that you are If I was you, I would sketch this right now. Notice how I have it. I have up here, I'm going to have to move it because I can't move my overhead camera that well. I have at the top percent grade in the form of vertical divided by horizontal. I also have uh, a, a problem here. I wanted to know what percent grade I would have if I had a horizontal of 15 and a vertical of 0.03. This tells me to take that 0.03 right here and divide it by the horizontal of 15, and it's going to give me hopefully I don't know if I've got two different problems going on, but let's divide that because I'm feeling like it should give me the grade, but I'm taking information from a slope which is no, not. Let's see. If I take 0.3 and divide it by 15, I'm going to get 0.02%, and that's what I was kind of wanted. What this is coming from is I'm going to build a roadway that's 30 feet wide, okay? I want a cross slope. In other words, from the center line of that highway, where's a good place? From the center line of I'm going to go like this, and then like this, and I'm going to say right here is my center line. This over here is 15 feet. This over here is 15 feet. And what I'm after is I know to shed water off this, I need a 0.02 fall or 2% fall. So the way I'm going to find out my elevation right here, let's say that this is like goes along here, not sure, let's say this is a back slope coming down, this is a back slope going this way. So if you can see, I have a highway going down through here, and this is the high point. This little dimension right here is what I'm wanting to know. So if I have a 2% fall over 15 feet, go back to the percent grade that I have up here, take the, let's see, what can we do? What do we know? We know we have a 0.02% grade. That's what we wanted. We have 15 foot on each side. That's what we wanted. So each side will rise 0.3. So this elevation in the center of the road is going to be 3/10 higher than both sides of it. So there's a practical use for that. Please copy this down. It will keep you from making mistakes. And and really, it's just up to you. I'm just saying it's a really good tool, and it kind of becomes entrenched in your brain as you go about your business, and you maybe even these tests, it'll come in handy. So let's see. I think that's all I want to do right there. I've got to get back to the other side. I sound like a sheep. I don't know why I'm doing that. Back to the sheep. Of course, I'm kind of a hillbilly. Really, don't 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 have good speak. Okay, we're back to the module. Now, remember, I don't do this. I'm sure it's doing the same thing. I just don't do long division. I have a calculator. Cheap one, but it's a good one. Same thing over here. What are they saying up here? They're saying figure 41, which is this guy right here, this whole thing. We'll get to what that is here in just a minute if you don't know. It's saying that in figure 41, there is a slope in the sewer line of 3.2 feet between station 6 plus 00, which is 600, same as, which is at elevation 275, and station 10 plus 00, which is 1000, and it's at elevation 271. Now, I'm guessing that if I subtract 271.8 minus 275, I'm going to get this right here, because this is what I need. This is the vertical. This is what I need to keep moving forward. So this slope can be expressed as 0.008, and this is obtained by dividing the 3.2 vertical by the distance of 400 feet. Go back to in your mind, I don't want to flip back and forth again. Remember, percent grade equals vertical divided by horizontal. So my percent right here comes from the vertical 3 2/10 divided by 400. I'm going to do that. I think 275 divided by, I'm sorry, minus 275 minus 271.8. 271.8 equals 3.2, my vertical. See, that's a difference in elevation, and that's a vertical. Whether it's going up or down, it's a vertical. It is a difference in elevation. These, where'd they go? Between this elevation and this elevation, there's a difference of 3.2 feet, and that is my vertical. So why can it be expressed as 0.008? Well, let's just see what we got here. We have a vertical distance of 3.2, and it's going to be divided by 400, because that's the formula, vertical divided by horizontal, which is 400. Now let me do that. See what I get. Vertical 3.2 divided by 400 equals 0.008. Now, that's what they have. That's what they said they would have. Where did it go? Now, this is another deal here, but up here they have 0.008, and this is what they're working on, is this clay pipe in here at a fall of 0.008 or 0.8%. So let's see what they're doing to us here. This is what we did. We divided 3.2, the vertical, by the horizontal distance, 400 feet, and that gave us 0.008. Now, if the slope was 0.4, 4/10 in a distance of 400 feet, the slope could be expressed as 0.001, but it's not 0.4. It's 3.2. So it's not 0.001. It is 0.008, as we first said. Okay, now I know this is going to be long, but there's nothing I can do about that. I want you to have this when you get through looking at this. You're going to know how to work these quiz problems. That's what I want. Okay, we looked at the piece of cheese a while back, and we saw a profile as if we had sliced that cheese right there. What we saw was a profile, and in this case, it actually formed a slope, didn't it? Because it was a slope. So this here is also a profile. Excuse me. And it's telling us, let's examine the profile first. What is what here? Uh, Note that the rate of grade is written along the top line of the pipe. That's right here. That's that 0.008. On road plans, the grade line is written, the grade for the road is what they're talking about, along the profile line of the finished roadway as shown in figure 42. And here's what they're talking about. This roadway line, and they don't usually put the bumps in it. They're going from, and by the way, this is a manhole. And the reason it looks so funny is when you do profiles, your horizontal scale is way different than your vertical scale. And these things, when they draw in according to both scales, they're going to look like towers, but they're actually manholes. And they're rather deep. I think these little lines right here are 5 foot, 10, 15. But sewer lines are deep in many, many cases, especially when the road is going up like this. Okay, so from this station to this station is the focus of our attention for the pipe, and they already got it kind of shown here from station 6.00, which is 600, to station 10 plus 00, which is 1,000. Did I say 6.00? I'm sorry. It's survey speak is 6 plus 00. And this is 7 plus 00, but that's the same as 700, that's the same as 600. So from here to here is 100 feet, right? From here, let me see that again, how I'm looking. From here to here is 100 feet. So this must be 50 feet. So this station right here would be, if they wanted them closer together, would be 6 plus 50. This station would be 7 plus 50. And that's kind of the way they do it. And if you put a culvert under the road here going directly away from us and coming directly toward us, they may put it at 7 plus 60 because it's close to 800. But it tells you where to put these culverts in, and they do it with these station numbers. Okay, let's move on from station numbers. When going, no, we can't yet. When station numbers, when going from left to right, you will assume that a grade are uh, is 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 positive. Uh, these station numbers go, no telling how far back here, all the way to 0 plus 00. And there's no, where the highway ends or where the segment of the highway and these station numbers will go in this direction. So I need to quit saying so. Uh, so let's look at we've examined the horizontal distance. Now let's examine the vertical elevations. See if we can figure out what they are. This little dash right here is 280. I'm just going to say it is. Okay. This, though it doesn't have a visible dash, does have a line that goes all the way and is straight across. And I'm going to assume it is 270, like it says. So if I go over here and go up to the bottom of the pipe, I should be somewhere in the neighborhood of 275. This is 270, this is 280, that's 10 feet. So I'm going to assume these to be 5 feet, and this 270, this 275, and then on up here 280. So the bottom of the pipe is 275 right here. Now, look over here. Station 600 is 275, right? That's the elevation. So we're probably pretty much on at station 600 calling this bottom 275. And by the way, the pipe is round. It's 8 inches, as it tells us up here, right here, and it's bituminous bituminous or something like that. That's that old orange clay stuff, I think. I don't even think they use it anymore, but they used to use a lot of clay pipe for sure. It doesn't rust. So it's an 8-inch pipe, but what's important on this pipe is, of course, it needs to be 8 inches because they're considering volume. And we don't want to make it any smaller, and we don't want to make it any larger because of cost. So let's go back to 275, and that is the bottom of the pipe. I don't know how thick the pipe is, but I do know that the flow line where the water or whatever's flowing down that pipe is going to be flowing down the inside of the diameter, the bottom of the inside of the diameter. That's going to be the flow line. So we'll assume this is the flow line. So the flow line here is at 275. And the flow line over here, can we follow the pipe down, is at what is that? It's not 270, but it's 270 point something, isn't it? Or it's 265.8. We can move over here closer to see where the bottom. What did they call it up here in the problem itself? They called it 271.8. So they're saying it's this 270, and then there's 1.8. It's not there. It's at 270. There, this is the top of the pipe is at 270.8. If they're going to do that, but I'm going to stick with 270. They said 271.8. No, it's not. It's the bottom, and that's what we're concerned with is 270. Now that makes us right now it's gonna come out different from them. But since we're using this, let's just call it that. And what's the difference in? I'm gonna mess this up if I do this. But let's just see if it's 270 instead of 271.8, it's going to be 2. Where is my dimensions? 271 versus 275. Now they're right, 275. They're right on target. But 271.8 is just not going to work. I'm going to see what that would do to us, though. So the inlet is 270. I forgot. 275. Didn't I say 275? 275. The inlet is 275. Now, I'm assuming inlet because I'm assuming gravity flow. The outlet is at 270 point nothing. It's right at it. It may be 270.1, but it's not 270.8 or whatever it's not 271.8. The top of it is, but that's not what we're concerned with. It's at 270. So we got 275 and 270. So that makes a 5-foot fall, right? If you look at this 270, am I on it? No, 270. Down 5 feet. No, 275 down 5 feet is 270. Okay, so 5 foot is our fall. So That's the vertical. Now, if I take, and this is over 400 feet, if I take that vertical of 5 feet and that horizontal of 400, I'm going to come up with a different number, but I just want to see what it's not going to be 0.008. It's going to be something else. If I take that vertical, it's going to be quite different. Of 5 feet, it's going to be a steeper deal. 5, and go to the formula, vertical divided by horizontal. So 5 divided by 400 equal. See, that puts it at 0.012, which is 0.0125, which is probably 0.013, we could call it, multiplied times 100. That would be, that's a lot flatter. The point at the 0.008 is a 0.8% fall. This right here, I'm really thinking here, 0.0125. 0.0125. I'm going to take 0.0125 multiplied times 400. Nope, it just gets me back to the 5 foot. So let's stick with what they're saying, because I'll have to go out on another tangent, and I don't want to do that. Let's just make sure we know this. But we do get a chance to use their information, put it in the calculator, and when we use their information, we come up with this 0.008. So I hope this helps you with the understanding what a road profile, this profile of a road. Let's see how steep this thing. This is curiosity. Elevation 300 feet at this manhole. Elevation at this point is 285. So elevation up there is 300. And down at the bottom is of the road is 285. That is a vertical of 5. I better do it with the calculator. We're almost done, guys. So 300 minus 2. That's a drop of 15 feet. That is a huge drop. Now, you got a vertical of 15. Now, do you want to know what percent grade that is? We need to divide it by, what is the distance I'm covering? Did I go to here? 400 feet. Yeah. Well, that'll do good enough for this. 15 divided by 400 equals. Now that's 0.04. Actually, 0.0375. So that is 0.04, which is 4%. 0.03. That's not a big deal there. I mean, 0.04. That's not a big deal there. Up here, they have it 0.4, which is way different than 0.04. 0.04 is 400ths. So that's a pretty steep fall right there as compared to 0.8%. We're at, percent wise, we're at wise, we're at 3.75%, 3.75%. So we're almost 4%, which is pretty steep. So one more thing, I want to go through this little these questions for you to get an idea of what's going to be on the quiz. It mostly centers around slope calculations as opposed to percent grade calculations. Well, let me see if I can drum these things up. All right. This is the test, I think. This is the test. How do I want to do this? I've got it all calculated, but I want to. Can I get one more thing up there? Not very readable, is it? No, I'm not going to do that. What I'm going to do, I'm going to turn on, can I turn on Elmo? That's not going to help me. Okay, guys. I know what I can do. Just give me a moment. I think I already have that in anticipation of what if this don't work. I'm missing a question. Hold on. Here we go. 2, 3, 4. And I have 6, 7, 8, 9, 1 more second. Promise. It won't take long. I had this all figured out. And I have misplaced one of them. Oh, here it is. Okay. We're going to get through a few of these. I won't have to do much calculating because I knew this was going to be a little time consuming. Now let's see what I can do to put things together. Okay. All right, get you out of the way. Have a look at the test. Do we see them? That's old stuff. This is newer stuff. What does the first question say? First question. Maybe you can read it, but if you can't, you can listen. The first question states this. On a 1.5, first question, well, the first question is number 2, because number 1, I didn't want to use it. Number 2 says on a 1.5 to 1 slope, the vertical cut is 3 8/10. What should the horizontal distance be? Well, let's look over here too. The vertical cut, let me bring 2 over into the picture. The vertical cut is 3.8. The slope ratio is 1.5 to 1. We put that in there. And what is 1.5? 1.5 times 3.8. What is that? I didn't write it down, but I did the rest of them. So I have to calculate this. 1.5 times 3.8 equals 5.7. 5.7. And if you look right here, that is one of the answers on this test. So my desk needs to be the size of a football field. So that's how we came up with our horizontal. We followed what this told us to do. We knew the ratio was 1.5 to 1. It tells us multiply this, and that gave us the horizontal, and lo and behold, it is one of the answers. Now, that's question 2. Question 3. I'll read it, point it out. The difference, let's move over a little bit. Okay, the difference between, oh, that's just a subtraction deal. I may have calculated that out, but all you're doing here is subtracting 4.72 from 4.8, and I had the answer written down just for the heck of it. Here it is. It's 0.08. That might be on a test, but it's a simple subtraction problem. It doesn't have anything to do with slope ratio or percent grade. So let's go to number 3. Here I am. Number 4, I mean. Here we are at number 4, and I'll try to read the question and jot down some things. Number 4, which of the following have the same relationship as 1.5 to 1? Now, ratio is a ratio is a ratio. 1.5 to 1 could be expressed in many different ways. You won't have many, if any, questions like this. This is a rare deal. But when I come across something like that, what else is 1.5 to 1? Well, I divide 3 by 1 and I get 3. That's not it. I divide 3 by 1.5 and I don't get anything. But if I divide 6 by 4, I'm going to get 1.5. So 6 to 4 in a slope is the same as 1.5 to 1. You understand what I'm saying? You know, if these are factored, 2 times 1.5, what is that? If you multiplied 2 times both sides, you would continue to get the same ratio, right? So that's all it's doing, and you rarely need to do this. When you do, it's just a matter of what makes the most sense. Well, 6 divided by 4 is 1.5, so these are the same ratio. Number 5, as you can see, we did it up here. It has nothing to do with what we're here for, of course. So let's look at number 6, and I bet you might have something for us to do that's a little more relevant to what we set out to do. Come in here with this. Number 6, and let's read number 6. Can we? There it is. Number 6. Now this is irrelevant. Facing a cut slope, I thought I got these out. You will be looking at which part of the properly installed lat. You're going to be looking at the flats, the narrow edge, because the operator going back and forth on the slope needs to see the flat side. I'm sorry that I didn't get that out. No, I'm not sorry. I just wish I had a minute to speed it up. So let's try number 7. See what happens there. This looks like it's going to make us do a little bit of work. By now, you may, out of desperation, you may have either gotten these or left the country. So number 7 states the slope necessary to build a slope of 60. The slope ratio necessary to build a slope of 60 feet vertical and 90 feet horizontal is. This is a case where you have the vertical, even though it's extreme, of 60 feet, but there are plenty of 60-foot high slopes and 90 feet long slopes. So what would the slope ratio be here? Well, look over here. We have the horizontal, we have the vertical. 90 divided by 60 is the same as 9 divided by 6. That's 1.5 to 1 again. So that's how we get that ratio. Now, I think we have a couple more, and I'll put an end to this. I want to make a brief mention about the tailgate, and that's it. So this is number 8. Number 8 says, at the top, you have a cut of 17 8/10. That's the vertical. And the ratio is 1.5 to 1. What is the horizontal distance to the toe? So the vertical is 17.8 at the top of the slope. The slope is 26.7 feet long at the bottom, like the cheese thing, this part. Remember that cheese thing we had? This right here is 17.8, and due to our calculation multiplying this right here is 26.7. So I think we have one more. I'd like to do it. Number 9. And that's all the questions I have. Maybe it'll be relevant too. Let's read number 9. Can we see number 9? Let's put it up here. Maybe we can. Number 9. If you had a horizontal distance of 13 5/10 at a 1.5 1 slope, and you could not read the cut, what would it be? How would you know? So we know 2 variables here. We know the horizontal distance to be 13.5. So we go over here and we put 13.5 in the horizontal slot. We know the slope ratio to be 1.5 to 1. So we go over here and we put the 1.5 over here. Now, what we didn't know, and when I put an answer up, let's leave it without an answer. So we got a little curveball thrown, but it's still all here. What is 13.5 divided by 9? That's what it's telling us to do, isn't it? I came up with 9. Can that be true? It doesn't look like it. Let's see. 3.5 divided by 9 equals, there it is, 1.5. So to find this, we did know that's 9. It gave us that, I think. We don't know the cut. We don't know the cut. I'm sorry. So to find the cut, which is the vertical, we have to take the horizontal and divide it by the ratio. I kind of got me a little lost on that. I got in a hurry. 3.5 divided by 1.5 equals 9. So 9's our cut. So going back to, I don't know where we're going back to, this little thing, we'd have a slope of, I lost that guy. Yeah, oh, we would have, this would be, yeah, this is it, 26.7 right here. That's number 8. Number 9 was the one we were on. I haven't done that yet. Oh, that's that irrelevant one. I guess we're done. Hallelujah. Okay, now just a word about the tailgate. By the way, you guys have done well on the tailgate. Keep in mind, plagiarism is both against the law, against school rules. Using AI is, I kind of like AI, but it gets misused so much. But anyway, whatever you do in your tailgates, you're doing a pretty good job, I think. Uh, Back to the module just for a second, and then I'll shut this video down if you're not asleep. Off with that, on with that. Get this put to bed. We don't need this anymore. And we can go up here and we can quickly go down to the module 3 where at look at the tailgate. So this tailgate, I kept it a little bit more structured. As you can see, I have I'm telling you what to do in this case. I get a lot of things that's like, what do you want me to do? Well, you need to get to the point where if we're talking about hydraulics, and like we did the other day, and I had all of these variables written down there, some of you actually put together and said, well, I could determine the pressure or this. Some said I could determine force. Think about it. Don't just immediately send me an email saying on week 3 tailgate number on the initial post, what do you want me to do? If you really don't have a clue, you know, I don't want you to sit there. You can text me or something like that, and I'll take a look and see if I can't give you a hint. So in this one, I'm keeping it pretty concrete. This is just an excellent thing, an excellent article. It is a really neat thing that some contractors are doing to help our planet stay our planet. We don't have anywhere else to go right now, so it behooves us to, regardless of what you believe and don't believe, something's different. Okay, so it wouldn't hurt us to recycle some plastic and things like that. So my daughter's drives me crazy with it, but she does it. Okay, these are some things I want you to keep in mind. Please don't start writing until you know what you're going to say. Read the entire article before you start to write. It makes a huge difference. Just jot down some things as you're reading it, what you want to say. I know when you start this, I can tell for sure you don't really know where you're going, and it shows. It glares at you when you're meandering. So, uh, no one sentence close. If you don't know something, there's nothing I can do about that. If you don't have another post, if you know something else to talk about that's related, talk about it. Other than what I ask you, I do these things telling you what to do. These are questions, but they're also confining, which doesn't really help a discussion. But I, if I leave it up to you, uh, until you get used to this, we we sometimes just get to the point where we don't know what to say. Do not write to get this over with. I want you to write to tell me something. Be creative. Uh, Relevance. That's one of the things that's for sure we need to. I have seen Chat GPT copied and pasted. Trust me, I know it when I see it. I can smell it a mile away. And there's some ongoing things right now that we're doing to eliminate that. AI is really a neat thing. I don't really care, except now we have a rule you can't use it. But even if you go to an article, and I say use your own words, when you use your own words and you're going to public it and it's going to be public, you need to be not plagiarizing. Like the author says to do this, put it in quotation marks. Or you could say, when he says this, I'm not really sure, but I think this is what it means. Make sure you're not plagiarizing. Make sure and the best way to do that is cite that document. I try to cite everything in clear form if I can. Chris Jackson with business, he's the business development manager with construction21.org, which is a pretty good site. So let the world know that you're not cheating. You know? So do the best you can and get creative, relevance, sentence structure, capitalize the word I when you're beginning a sentence. We're not texting, okay? Don't do IDK, in small letters for sure. I don't know. Now, I'm going to use a contraction from time to time in my comments, but I'm encouraging you not to get in the habit of using contractions. I have a tremendous load when it's time to grade, and if I give you the attention you deserve, I don't have time sometimes to not use a contraction. Okay, that's the end of the video. Have a good whatever's next, and let me know if you need help.